Hello, I'm Brian Farrell, and welcome to PACE IT session on the Introduction to the Power Supply. Today we're going to be talking about alternating current versus direct current. Then we're going to be talking about the PC power supply itself, and then we're going to be talking about some things you need to consider when choosing a power supply. And with that, let's go ahead and begin this session. And we begin by talking about alternating current versus direct current. So let's start with alternating current, AC. The common source for AC is your wall socket, and the most standard unit of measure of AC is in volts. Now we use alternating current because it's a better medium for transmitting power, especially over distance. Now a characteristic of AC is that the electrical charge periodically reverses, which is represented by a wave. The reversal cycle is measured by the frequency of its change and is represented by its Hertz value, which is the number of cycles per second. Now your most common voltages in the United States and Canada is 110 to 120 volts at a 60 Hertz cycle. The most common wall current in other countries is 220 to 230 volts at a 50 Hertz cycle. Direct current, DC, on the other hand, is usually either derived from converted AC power or from batteries. Direct current is a constant power. There is no reversal cycle. Now, DC works best for applications that need to store electrical charges, like a battery, or that require the constant power characteristic of DC, like computers. Computers require DC current. So talking about PCs, now let's talk about the PC power supply. So let's begin with the power supply's job description. It needs to take the AC wall current and change it to the appropriate direct current that the PC requires. And it needs to do so in the right amount. Not only does it need to supply the correct amount of DC current, but it also needs to supply it through the appropriate style of connector. Now the common voltages that a PC requires are 3.3 volts, 5 volts, 12 volts, and negative 12 volts. Yes, I did say negative 12 volts. Now power supplies are rated by the watts that they can supply. The watt is a unit of measurement for electricity. Watts can be determined if you know voltage and amperage. The formula for that is volts times amperage equals watts. So earlier I mentioned that the power supply needs to provide those voltages to the proper connectors. So let's talk about those connectors. There is the 24-pin main motherboard power connector, and it supplies 3.3 volts, 5 volts, 12 volts, and that negative 12 volt current that I talked about earlier. You use a 24-pin main motherboard power connector on most ATX form factor motherboards. There's also a 20-pin main motherboard power connector, and it supplies the same voltages that the 24-pin does. And this connector is for the micro ATX and smaller form factors. Today's CPUs tend to be a little bit more power hungry than in the past, and will require more power than what the motherboard can supply. That is where the 4 or 8-pin auxiliary motherboard power connector comes into play. Now it supplies additional 12-volt current for the CPU. You may also find the 4-pin Molex connector. This supplies 5-volt and 12-volt current, and it's used for some peripheral devices and for a lot of fans. There's also the Berg connector. That supplies 5-volt and 12-volt and was commonly used on floppy disk drives. You probably won't find too many Berg connectors on modern power supplies. Then there's the SATA connector. This supplies 3.3, 5, and 12 volts to SATA devices. It uses a 15-pin plug, and finally you may have a 6 or 8-pin PCI auxiliary power connector. This supplies additional 3.3 and 12 volts to some PCI add-on cards, specifically those that require it, which are commonly video graphics cards. Now let's move on to choosing a power supply for your PC. So the first thing that you need to do is you need to know the form factor. ATX, micro ATX, and ITX use different standard sizes for their power supplies. You cannot physically put an ATX power supply into an ITX case. It just won't fit. You also need to know your voltage requirements. Are you in the United States and Canada, or are you most of the world? So do you need that 110 to 120, or do you need the higher voltages that the rest of the world uses? Now, some power supplies can switch or be switched between standard voltages, but on the other hand, some cannot. You also need to know what is going on inside your case. What type of motherboard and CPU do you have? Do they need more power? What type of connector does the motherboard need? Also, the types and number of peripherals that you have inside your case will help to determine what kind of power supply you put inside that case. And along that lines, knowing your wattage requirements is beneficial. It's better to have more watts available and not need them than to need more watts and not have them. In other words, it's better to choose a larger power supply and have an abundance than to choose a smaller power supply and starve your system. Now that concludes this session on the introduction to the power supply. We talked about some of the differences between AC and DC power. We talked about the PC power supply itself, and then we talked about some things that you need to consider when choosing a power supply. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure we'll do another one soon.